Let's move on to 10.3, learning outcome number 2. Okay, deduce the relationship delta U CVM delta T from the first law of thermodynamic, and then we're going to derive and use the equation for CPM minus CVM equals to R. So today's lesson and today's video is about number 2 and number 3. Alright, so let's look at the first one. Okay, now here. Okay, figure 10.5 shows the initial state and the final state of 1 mole. Okay, the key word here, class, it is 1 mole. Okay, 1 mole of an ideal gas. So that means this is N equals to what? 1 mole. Okay, alright. Now we have this situation here. Okay, we have this container filled with gas here. The first situation at the initial state, which will be initial state, we know pressure, pressure P, volume Vm, and temperature is T. Okay, and then final state, we know pressure becomes P plus delta P. From P, it became P plus delta P. That means pressure increase lah. Okay, then we know Vm still become Vm, so that we know volume constant lah. And then why we use the M is because it says the word here 1 mole. Okay, alright. So temperature T initial, then it become T plus delta T. So that means T increases. Okay, so T increases. Alright. Okay, so if I draw, class, I want to draw a table based on the situation. Okay, now first thing, okay, let's look, you all look at figure 10.5, yeah. Okay, first thing, let's talk about the volume, which is Vm. Okay, we know volume same. Okay, or in other words, we say volume is constant. Okay, next, we know volume is associated with work. So since volume is same and constant, and the formula we know that work is P delta V, so that means work is 0. Alright. Okay, pressure. Okay, pressure is increase. P, it increases to P plus delta P. Okay, I'm referring to figure 10.5. Yeah, I'm just doing some analyzing here. Okay, alright, next, temperature. Okay, temperature T. I notice that the temperature also increases from T to T plus delta T. Okay, now internal energy. If temperature increase, I know internal energy will also increase. Okay, so delta U will increase in the gas. Okay, and then heat capacity. Heat energy. Alright, sorry for that. Heat energy Q. Okay, heat energy Q, if I look at that, I can use anywhere in these 4 formulas. So which shall I use, class? Okay, so it looks like it says 1 mole and the volume is constant. So that means I use Q equals to N CVM theta. Okay, Q equals to N CVM theta. I'm not going to use theta because the book use delta T. Okay, the book use what? Delta T. So I'm going to use delta T. Alright, you can use theta or you can use delta T. Okay, and since N equals to 1 mole, so Q equals to CVM delta T. Alright. Okay, so these are all the information I got, class. So I use the first law of thermodynamics. Says that Q equals to U plus W. Okay, what is Q? Q is N CVM delta theta. CVM delta theta. Delta T, sorry. Okay, and U is, I should always put the U, put delta U. Delta U is delta U plus W. W is 0. Okay, so W is 0. So delta U equals to CVM delta T. Alright, so this is one formula. Okay, when volume is constant, this process here is called as isochoric process. Isochoric process. It has a lot of name. You can call it isochoric, you can call it isometric because it's in meter cube, right? Volume. Okay, you can call it isovolumic, isovolumetric. This is iso. Iso means same. So same volume. Okay, so this process is called as isochoric process. Okay, alright, so this is the first process. Okay, now let's look at the second process. This process, let's look at figure 10.6. Okay, if you look at the figures 10.6, it's still maintained with the word 1 mole. That means N is equals to 1 mole. Okay, sometimes I always use MOLE for bahasa. Comes from the bahasa background. Okay, anyway, look at this. So initial state is P, Vm and T. Final state is P, Vm plus delta V, then T plus delta T. So what do I study from this class? I notice that the pressure is constant. Pressure is constant. Okay, and then second one, what do I notice? Vm became Vm plus delta V. So I notice volume increases from Vm to Vm plus delta V. Okay, what else do I notice? Temperature plus delta T. So I notice that temperature increases from T to T plus delta T. Okay, alright, now let's look at this. I'm going to do a table based on this. Alright, I'm going to do a table. Wait, let me draw a table. Okay, let's look at the first one. Let's study the first one. Okay, volume. Okay, what do I know about volume? Volume increase from Vm to Vm plus delta V. Okay, then of course volume is associated with what? Work. Okay, and what is this? This is work done by gas. Correct? Work is positive. Okay, if you want to add another keyword, you can add under volume. Gas expand. Okay, next let's look at temperature. temperature increase. Okay, temperature increase. Alright, from T to T plus delta T. Okay, next let's talk about internal energy. If you notice here, I use one quantity, one thermodynamic quantity, one quantity, one thermodynamic quantity. Alright, so internal energy will be delta U will definitely increase because temperature increases. Okay, so therefore let's look at pressure. Pressure constant. Then we look at heat. Heat. Okay, heat here, we know pressure is constant and then we know it's under 1 mole. So therefore, if I want to use the formula class, which formula of heat energy shall I use? Definitely Q equals to NCPM theta. In here, I'm going to write down and Q equals to NCPM theta, which I'm going to replace with delta T because of the textbook. Okay, delta T. So since N is 1 mole, so Q equals to CPM delta T. Okay, this is analysis from figure 10.6. Okay, alright. So then what happens, class? We use the... Alright, let's use stages by stages. Okay, now from ideal gas concept, I'm going to use a red pen. Before I forget, this process is pressure is constant. So this process is called as isobaric process. Baric is comes from barometer, so it's isobaric. So iso means same. Baric is also associated with the unit of pressure, so therefore isobaric. Okay, all right. Okay, baric is something associated with pressure. All right. Okay. I want to say something, I forgot already. Okay, now from ideal gas. Okay, PV is equals to nRT, correct? Since N is 1 mole, so becomes PVM equals to RT. Okay, and then we substitute this value inside here. PVM is what? VM plus delta V, or T is what? T plus delta T. Okay, this is 1, this is 2. Alright, so you will notice that the book will take 2 minus with 1. Okay, here it says 4 minus 3 lah. Okay, but I take 2 minus 1 based on my example. 2 minus with 1, you get P delta V equals to R delta T. Concept number 1. Okay, alright. Concept number 2. Work done, W equals to P delta V. Correct? Work done, W is P delta V, and you notice it's a positive because work done by gas. P delta V is equals to R delta T from concept number 1. So W equals to R delta T. Okay, now concept 3, thermodynamic law. First law, Q equals to delta U plus W. You can also put delta Q, class. Okay, Q equals to delta U plus W. Okay, Q is CPM delta T. CPM delta T. T. I'm going to remove my textbook here. Okay, CPM delta T. Delta U. Let's look at delta U, class. In figure 10.6, delta U T to T plus delta T. In figure 10.5, delta U T plus delta T. So you notice they are similar process, correct? So therefore, we can use delta U equals to CVM delta T inside this formula. Okay, CVM delta T. Alright, plus W. W is R delta T. Okay, now cancel, cancel, cancel. I'm going to continue here. Okay, which is CPM equals to CVM plus R. Okay, then I bring to the other side. I will notice CPM minus CVM is equals to R. And I can say from this formula that CPM is greater than CVM. Okay, alright. Okay, so you have to know this, class. Alright, this is how I studied two diagrams, figure 10.5, figure 10.6. Then I use the whole concept to get the formula CPM minus CVM equals to R. And if you see under your learning outcome, you need to know how to derive and use the equation. So this one you have to learn how to derive. It's in your syllabus. Okay, this you will notice all that I've explained here is inside the paper that I've written. But if you look here, this is explanation by graph. Okay, now figure 10.5. Figure 10.5 is isochoric process. So if you notice here, it has put isochoric process. Okay, each process, this is point. A process is from one point to the other point. One point to the other point. So if you notice in figure 10.5, okay, you notice in figure 10.5, you will notice that the volume is constant. So that's why volume is constant. So it is called as isochoric process. This is an isochoric process. Okay. And then you use figure 10.6. which is this. You will notice pressure is constant. Okay, so you notice in this, from this point to this point, you will notice the pressure is constant. So it's an isobaric process. So this is from figure 10.6. This is from figure 10.5. So the explanation is based on graph. Okay, alright. So from each explanation here, I can already explain here that the pressure is already increases from here to here under volume which is constant. And then I can tell you when the pressure is increases, the volume is constant, no work done. And then actually you will notice the temperature will increase. There's another line. This is called as isotherm line, which I'm going to teach in the next lesson. Okay, so that will hold on first for a while. So more about this graph will be on later. Alright, so that is all, class, for this chapter, for now, which I've already done learning outcome 2 and 3. So the next video will follow for the other 2. Okay, so that is all for today, and I will give you all homework to do, class. Alright, so thank you.